Alright, so we are in geometry. Today's date is Friday, January 31st. It's a minimum scheduled day, so we're going fast. So we're going to we're still using trig ratios, and now we're finding angles, so we're going backwards. Gunnar, our objective today is to
use inverse trig functions to find angles in triangles.
Exactly. So this is kind of a very key point. If I'm ever trying to find lengths, I'm going forwards. If I'm trying to find angles, I'm going backwards. And it's something that you really have to keep in your mind, like, what is it asking for? If it's asking you to find the angle, then you're going to be using reverse trigonometry. If it's asking you to find a side length, you're using forward normal trigonometry. All right, so as a review, use your SOHCAHTOA. Sine is equal to what over what? With a quiet raised hand. Gunnar, your card is already in. Sorry, Jose. It is indeed opposite divided by hypotenuse. What about cosine? Quiet raised hand. What is the ratio for cosine? Zoom in here. 2 people know? I need more people to know. SOHCAHTOA.
Wait, can you know but not answer?
I want you to answer.
But I don't.
Yes, Julian.
Huh?
SOHCAHTOA. Ka. Yep.
Oh.
Sound it out. Ka. What letters are you using? C.
U.
No. You only have O, A, and H. Those are your only letters you got to use. So ka not O but
So cut.
A over
Oh.
O over H. No, A over H. Okay, so adjacent over hypotenuse.
131st.
All right, thank you. And then finally tangent. Jenny.
Op and adjacent.
Opposite over adjacent. Thank you. All right. Let me get rid of that guy. All right, so we're going backwards today. The general idea is, what happens if I say, hey, I know what the trig angle is. If I say sine of the angle, the ratio that sine is telling us, the ratio of those sides of opposite over, so opposite over hypotenuse is 1 to 2. Well, if I know that, I should be able to go backwards. That's the whole idea with math. If I give you an operation, I'll give you the undo button as well. I'm learning the undo button to figure out what that angle was. Yesterday I gave you an angle, and then you were able to say, oh, here is your ratio. Today, backwards. So, how do we do that? And the answer is using arc sine. So the way that I write out in terms of how to spell this thing is called arc sine. A faster way of writing this is sine to the negative first power. These are the same thing. Even oh yeah, question.
Is arcsine like the one word?
Arcsine is one word, yes. So if I went to not there. If I go to desmos.com/scientific and I look at arcsine of a value. So if I say sine to the power of -1 of, I don't know, so 3 divided by 4, it's 48. If I do arc sine of 3 divided by 4, I don't know why I added the extra parenthesis, it's the same number. These are the same thing. You can use the same thing on the calculators. Just know that it's pronounced arc sine. I'm going to be using this notation because it's a little bit faster. And it makes a little bit more sense too. So I'm going to come up here to undo sine. To undo this trig function, I'm going to take the arc sine of both sides. Arc sine of both sides. When I do that, the arc sine and sine will cancel each other out because one function undoes the other function. So you're going to cross out your arc sine on the left and your sine on the left, but this arc sine on the right-hand side stays behind because that's not undoing anything. Which means we can say now that theta is by itself because arc sine and sine are gone, so I just have theta on the left-hand side. On the right hand side, I have arc sine of 1/2. Well, let's figure out what that is. So I'm going to type that into my calculator. What is arc sine of 1/2? And you come over here and say, you can either type it arc sine if you'd like it that way, or you can say sine to the -1 of 1/2. Either way, my answer, and let me move there, is 30.
How do you?
Make sure you're in degrees and not radians, because we're always going to be in degrees for now. This is 30 degrees.
That's not that hard.
It seems pretty straightforward, right?
Yeah. Is it hard though?
I don't think it's too hard. It's a little bit hard to like do it when you first begin, but it gets easier the more you do it. So this is going forwards. This path right here on the left is going forwards. I'm even going to write forwards. Going forwards, I was given an angle, and then I took the sine of that angle, and I was able to figure out what the ratio of the opposite to the hypotenuse. But if I'm given the opposite over hypotenuse, or some ratio, and I want to figure out the angle, this is going backwards, I need to use arc sine. I'm going to write both of them. So there's arc tangent, arc cosine, and arc sine. Question, Andres?
Will this be on YouTube or? Because
This-
I want to rewatch this video.
This will be on YouTube with like by break. All right,
Usually I get a notification for it at like tomorrow.
that's interesting. It should be up sooner than that. All right, so trig functions. These are all the ones that you're learning today. So again, these are given you. So when I take the arc sine of the opposite divided by the hypotenuse, this will give you the angle. When I take the arc cosine of the adjacent divided by the hypotenuse, that will give me my angle. My angle will always be equal to these arc, or these the inverse trig functions.
This seems really easy.
I'm glad. So I don't want to keep writing thetas. All of these are thetas equal. These are all angles because I'm taking the opposite of the ratios. If I take the opposite of the ratios, I get to an angle. If I take the normal trig function of the angle, I go backwards to the ratio. It's this switch between ratio, angle. And then, of course, how to pronounce them. Arc sine, arc cosine, arc tangent. So, and I still cannot understand why mathematicians have not fixed this yet. There are a few things in mathematics that need to be fixed. One of them is pi and tau. And that's a discussion that we can have at a different point. We probably should have had that discussion already. But this is the other one that needs to be fixed and you have to be careful of. When I write 3 to the -1, that is 100% equal to 1 over 3. Because if I wrote this as 3 to the -1 over 1, whenever I flip it, these become positive. So this is really 3 to the positive 1 now. I'm allowed to flip with negative powers. Negative powers now do not mean the same thing. I'm not allowed to flip sine and make it a positive 1 power. So when I say arc sine of arc sine of x, that is not 1 over sine of x. So just go into this knowing that it's not 1 over sine of x. We're all okay with that? All right, let's move on to some problems now. All right, so I'm giving you two lengths, 30 and 65. I don't know if those are on the opposite, on the adjacent, if they're on the hypotenuse. But I do know that I'm trying to find an angle, which means if I'm trying to find an angle, I need to use arc, cosine, arc tangent, arc sine, one of those. So the first thing that I'm going to ask for a quiet raised hand is, what are these things? Opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse. What are they? Label them first. Quiet raised hand. Who has their card? Raise your hand with your card. No, you don't have your card anymore, sorry. You can go ahead and label it on your own. Andres.
It's the opposite over adjacent, or adjacent over opposite.
Which one is the opposite?
30.
30 is the opposite.
And adjacent is 65.
Adjacent is 65. And therefore, which trig function are we going to be using? What uses opposite and adjacent? Okay, so tangent. Perfect. Thank you. I'm going to help set up the rest of this. So we don't know what this thing is. So instead of calling it x, we usually like to call our unknown angles theta. So I'm going to change this out for a theta, not a question mark. So I'm going to say tangent of theta is equal to, and I know it's going to be opposite over adjacent, so it's going to be 30 over 65. So the first step in the last lesson and in this lesson is set up your normal trig function by the definition. One of these is going to be unknown. Maybe that's the unknown, maybe that's the unknown, maybe that's the unknown. And now we solve. And if you look at the front side, this is almost the exact same problem. I need to undo tangent to find theta. I can't divide by tangent. That's not how it works. The only way to undo tangent is take the arc tangent of both sides. So I kind of apologize now. We should have given ourselves some more room to write arc tangent right here. So if you ever run out of room, you can kind of just write it off to the side and say tangent of -1 of all that. But because I have technology, I am going to just move this all to the right-hand side to give myself space to write. So I'm going to write arc tangent of both sides. So I'm going to say tangent to the -1 of the left-hand side and tangent to the -1 of the right-hand side. Again, it's still an equation. It's still a balance. This side, the left side, and the right side have to be balanced. So whatever I do to the left side, I must do to the right side. I'm taking the arc tangent of both the left and the right sides. All right. I need a quiet raised hand to tell me what I'm supposed to write on the next line. I'll do the calculations for us on the calculator, but what should be on the left-hand side with a quiet raised hand? You should have your card turned in by now. Fernando?
Beta, and then equals.
Equals whatever that is, right? Because these tangents cancel each other out. So I'm going to go ahead and type this in for us, and then on example 2, you're going to use your own calculator. By the way, the reason that I like using this notation is because this is what your calculator says. Your calculator has tiny buttons, and it doesn't have the space to write out arc, tangent, or even arctan. It's quicker and shorter to have the tangent to the power of -1. So that's the reason that I do it. It matches the calculator. So if I come back over here, 30 over 65, arc tangent of 30 over 65, and my answer, do we need to round to the nearest thousandth? So with a quiet raised hand, how many decimal places should I be rounding to for this nearest thousandth? Cone did the warm-up. Monse? Ooh. Yeah, so three decimals. So if I come back over here, I look at the third decimal place, and I say, okay, am I rounding that up or down, judging by the next number? Who can round to the third decimal place correctly with a quiet raised hand? Yes, Jessica.
I'm blind, I can't see it.
That's as much as I got.
It's gonna be 4.78.
So I'm going to round based off of this last number. So does this 5 turn into a 6 or does it stay a 5?
Oh, it stays at 5.
Stays a 5. So my final answer is,
24.775.
there it is, 24.775. And we usually have the units of degrees. It'll automatically put that in for you. I think if you are typing on the computer though, let's see, if I go to hit enter here, if I hit option 0, yeah, option 0 on your Mac will give you the degree symbol if you ever need it, which you won't. All right, so not in the near future at least. We have one final example. I want you guys to solve this on your own. You're going to need your calculators, so you can either grab one up here or you can use the one on your computer. I highly recommend using one on your computer because it looks nicer. I need you to find the angle. What is angle ACB? What is this missing angle? All right, good luck. All right, so first I need to label these opposite, hypotenuse, adjacent. Josie, you want to do that for us?
So 7 is adjacent.
7 is adjacent. Oop. Hypotenuse. Perfect, thank you. Did you also want to set up the ratio or do you want to let someone else do that? All right, Andres?
Alright, so it's gonna be cosine. And then in parentheses, theta equals 7 over 9, since 7 is the opposite, or the adjacent, and hypotenuse is 9.
Perfect, thank you. And someone else, what am I going to do to both sides of the equation? Sergio?
goes to -1.
Yeah, how do I pronounce that thing?
Oh, wait.
What is this called?
Arc
Arccosine. Say it one more time.
cosine.
Perfect. Thank you.
Perfect.
And therefore those cancel out, and we're left with theta is equal to arc cosine of 7/9. Come back over here. Arc cosine of 7/9. And rounding to 3 decimal places, so does that 2 go up or down? It goes and stays the same, so 38.942. 38.942 degrees. And we should be boxing our answers. Did I box my last one? No, I did not. Go back and box all these answers. Those are the only two. Okay, cool. That concludes our notes. Fist of 5, how well can you use inverse trig functions to find angles? Really quickly. 5, 5, 5, 5, 4, 4, 4, 5, 4, 4, and whole numbers. I'm going to give you a 4. All right, thank you.